Hello, alright, today we're going to go over sorting algorithms, which a sorting algorithm just takes a list like 3, 5, 2, 7, 4 and it sorts it. So let's say we want to sort it in ascending order, that means from least to greatest. Then it would come out with the list 2, 3, 4, 5, and 7. Alright, now there's all sorts of ways that you can do this. That would be there's faster ways to do it and slower ways, and ways if you've got bigger lists or, that are more efficient if you've got a bigger list, or more efficient if you've got a list that's already been mostly sorted. But we're just going to look at like 1 or 2 ways to do this. In future computer science classes, if you choose to go on with computer science, you'll learn different ways to sort. But we're just going to look at the simplest way. Now, also you can sort other things besides numbers. You can sort like names, like Billy, Angus, Ted, and of course it would come out with Angus, Billy, and Ted. Alright, and let me show you just how to do this real quick, how to compare strings, because since that's something you'll have to do. I think it's string less than Billy, Angus. Yes, that's it. Alright, so you see Billy is not less than Angus, lexically speaking, because it has a B at the start instead of an A. Alright, and then I think if you do string CI like that, then it will be case insensitive. So Billow should be first here. Alright, yeah, so Billy's not less than Billow, Billow's less than Billy. And it just ignores that this is a capital B and that's lowercase b. So you might want to use this like if you're sorting names out. Because otherwise, I can't remember which, but I think the capital B would be lexically smaller than the lowercase b. Alright, but you'll have to do some name sorting in your homework. That's why I bring that up. But for now, we're not going to do that. For now, I'm going to show you how to do the procedure insertion sort, which is one of the most simple inserting algorithms, and it works in basically 2 parts. The first part is just a function called insert, and that takes an element like 5 and it takes a sorted list. So let's do like 1, 3, 8, 9. Okay, so that list is sorted. It has to be a sorted list. If it's not sorted, then it's not going to work right. Alright, so and what this will do is it will just go through and it will output a new list with 5 inserted in the right place in this list. So 1, 3, 5, 8, 9. Okay, so before I get on in, to explain the rest of the insertion sort algorithm, let's just try and program this in. And why don't you go ahead and pause the video and try and program it in yourself, and then I'll show you how to do it if you after you've tried it. Okay, so assuming you've tried it already, or if you're just not going to, then we'll try it now. Define insert. Okay, so what's our strategy here? We're just going to check and see. So we'll get the list here. We'll check if 5 is less than the first element of the list, and if it is, then we'll create a new list with 5 at the head of the new list, and if not, then we're going to have to run insert on the coulter of the list. and what are we going to do with the 1 that 5 went by? We're going to have to cons that back onto whatever new list we create. Okay, so let's get defining this. A lambda A, we'll call it from, I don't know why, atom maybe, and then SLS is what I'll name the list because it's a sorted list, so the S stands for sorted. Alright, so we're going to have some base cases here. So cond, let's see, if the list is just empty, then let's say we've got insert on an empty list. Insert 5 into the empty list. Then of course all you want to do is do 5. Okay, so that's the base case. So let's write that down. Null SLS, then list A. Alright, and this also would be if it went through every single element and got to the end of the list, then we're going to have to put the element at the end of the list, so we'll want to end up with a list of 5 anyways. And alright, so otherwise let's say that let's do a comparison. Let's say 5 that A is greater than or let's say it's less than A is less than the car of the sorted list. Alright, so if it's less than the car of the sorted list, then we want to stick it in front of there. So like when we get to 8 here, then we want to stick the 5 in front of it. So let's cons A onto LS at the time, because by the time we get to 8, 1 and 3 will have dropped off. We'll just have this list left. So let's cons A onto just SLS, and that will be the answer. Except what about like the 1 and 3, because we've passed those by, so we have to make sure with those. So let's say else else meaning that A is greater than or equal to this element, then let's cons the car of SLS onto the insert A of the coulter of SLS. Alright, and that way these trailing ones that get passed up will still reattach themselves onto the final list. So in this one it goes through and it does this else 2 times, so we've got basically we've got cons 1 onto the cons 3 onto the, and then it runs insert 5 of this 8 and 9, and it goes to this case here and it just conses 5 onto 8 and 9, so onto the cons 5 onto the list 8 and 9, and we get that final list there. And supposing you know, this would be 15, then it would have just gone here until the empty list. We would have const on all those on to the list of just 15. Alright, so let's check and make sure that works. I'm pretty sure it will work. Oh, I'm not so sure anymore. Alright, we've got to do the parentheses. Now let's run that. Insert 5 onto 1, 2, 6, 8. Alright, that works. Okay, good. Now the second part of insert is sort of clever and tricky. So let's say we want to insert, second part of the insertion sort algorithm. Okay, so let's say we got 1, 3, 6. Oh, blast it. Yeah, let's say we got, well, actually I'm about out of time, so let's I'll save this for the next video.